Alright, hello everyone. My name is Alex and it is great to meet you if I haven't already met you. If I have, it's good to see you again. So, tonight's talk is called Grabbing the Flame. When I was younger, when we were growing up in our home, we had a fireplace. I don't know if many of you had those. That was the main source of heating for our house. And it was sort of my job during the winter months to put that fireplace together. And I really loved doing that, and I still love doing that today. So the idea of putting the the paper together and then the kindling and sort of building up this fire that gets bigger and bigger, and it's sort of this really great reward at the end where you get to sort of sit down and just watch it. I just really love watching fires, and I feel like I have some of my best conversations just watching them. I don't know, there's something about them that is very relaxing for me. And that's sort of the vibe that I'm hoping to go for tonight as I talk about three different stories sort of linked together by this idea of trying to improve performance in a React application that I work on. So here we go. This is my first story, and this is called Moving Naturally. So a little bit of context. You've probably heard me talk to death if you've been at this meetup a few times before about this library, but I work on a library called react-beatutiful-dnd, and a big part of this, the driving idea behind this library is to have a drag and drop experience that feels more natural, feels more grounded in physical metaphors, so that hopefully it's more relatable for people. And this movie is just going to keep living over and over, it's just the same movie. But what it's showing here is just highlighting one effect, which is the drop animation. So in this example, if you pull something away and just let it go, it kind of falls back to where it started. And I put a lot of effort, we put a lot of effort into this animation to make it feel hopefully like you're dropping something that's physical. I think often with CSS animations, it's easy for them to feel quite flighty or weightless. So we've really tried to invest in this animation to make it feel like you're dropping an actual object. And how we do that is we use a library called react-motion. There are other animation libraries for React which do a similar thing. And the idea is that you declare... Oh, let's see if this works. Oh, it's not going to work. That's okay. Okay, so up in the top... I'm going to see if it's actually not working. Why not? Come on. Oh, that's okay. Anyway, so you define the animation in terms of physical characteristics. So in this case, stiffness and dampening. And then you say, I want to move to a position, in this case, position 10. And you let this library figure out how to get there. And what's interesting about animations like this is you don't define the animation in terms of duration or curve. Rather, you set up properties about the object and then let the animation run. And what's cool about this is that we will tweak these values for a long time to get them to feel like you're dropping something, dropping an actual object. So the animations can run for a flexible amount of time. We don't specify how much that is, and we let React Motion take care of that physical drop. So while I was building the new version of Beautiful-dnd, which is coming out in the next 1 to 2 weeks, I had this idea that I floated to a colleague of mine called Jacob Miller. And I said, could we create something that is the same or almost the same, just using CSS? Because if we could do that, then we could drop React Motion, which saves us kilobytes. But hopefully also we could move that work from the CPU to the GPU. So if you're doing animation work using request animation frame, you are doing that on the main thread, which means you're competing with other things that are going on the main thread. Whereas if you can move it into CSS, then the GPU will take care of that work for you, which is pretty great. So what Jacob did, he's a prototyper and he is an absolute wizard. He went away and he didn't even look at the code at all. And what he did is he plotted a graph. He just plotted percentage of distance traveled versus percentage of time to finish the animation. So he tried moving things a little bit away, far away, to see what curve this would generate. And what he found was that regardless of how far away the item was, it was generating a consistent animation curve every time. so this animation curve here. The thing that was changing was the duration of the animation. So the animation curve was consistent based on our spring, but the duration was different. So this is the same movie I showed you before, because it's the same. So this, we swapped out React Motion. We're now using that generated animation curve. Oh, it's not playing. Did it play? Yep. Oh, it's not going to play. All right, pretend like it's playing. Oh, wait. There we go. So this is now using CSS with a dynamically generated duration depending on how far away the item is. And so we were able to drop React Motion, and we were able to move all that work from the main thread off onto the GPU. This resulted in 66% more frames when dropping in high load circumstances. So for most people, it's usually 60 FPS anyway when you're dropping, but this is like with a list with 500 things. When I throttled the CPU down by 4 times, the CPU versus went down to 20 frames per second for dropping, and the CSS one remained at 60 FPS. So anyway, so yeah, about a 66% gain, and they will vary depending on how much load you're putting under it, which is pretty sweet win from moving to that technique. And also, as a side benefit, because we're no longer like React Motion and other motion libraries, like they sit in your tree, and there's extra overhead in that, and like they do some React Motion anyway does some processing even when you pass in data like straight through. When you say like, don't animate this, that's when I move straight here. There was cost in that, but as soon as we dropped that, all that cost went away. So this is not even during the drop. This is like another phase of the life cycle. Is now 25% faster by just dropping an animation library, which is pretty cool. So this is an adventure for another person. This is an idea for someone out in the audience or watching remotely. Spring to CSS. So in our case, what we did is we had a spring value that we liked, and he went into the browser and like reverse engineered an animation curve and duration that was the same. And that was a very manual process, but thankfully we don't need to, we just generate it once and use it forever. But it'd be cool if there was a library that like you provided it with a spring and spat out an animation curve with a dynamic duration. I have seen one on NPM, but I haven't looked at it. There's one I think called CSS Spring, but anyway, so that's an idea for someone. And what's I think more interesting is if you could generate those curves at build time rather than runtime. So because these curves are, you spit out a value, especially if you're only using them once, like ideally your build would just generate this curve for you, and then you just give the client the curve rather than them having to like compute what that curve should be. Now again, this is, I didn't have a slide in for this, but these are like caveats. For us, we were a good candidate for this technique because we have a one-time animation that runs. We don't change its destination midway through. We have one spring for everyone, like everyone had the same spring. We didn't change the spring for anyone. So all those sort of factors meant that it was easier for us to move to CSS to do this. But what's super fascinating is that we got like the exactly same feeling drop. Like we didn't have to compromise that, and we were able to do it with CSS, which is pretty great. So that's my first story. That was a nice one. Here's the second one. Oh yes, you're welcome. Yeah, so that'll be coming out very soon, which is great. So my next story is hot functions. So again, here's that same movie that I was playing before. When we pick something up in a drag and drop operation, we do a fair amount of work. So we collect the dimensions of the things that we care about, and we process them, and we store them in a virtual model that we store internally, which we then use for the duration of the drag. We have to do it at that point because we don't know. We don't know if we don't want to be doing it on mounts because things could change after that. This is like the most reliable time to collect information, but it's also the worst time because it's just when the user's trying to do a drag and drop operation. So in a previous release, I optimized this in a crazy amount, and I spoke about that here as well. And it's pretty good, but I was thinking, could it be better? So not changing the approach because the approach is already like very, very optimized. Could I get the functions that are already there to run faster? So a little bit of detail. Unfortunately, I can't use my pointer because it's not working, but those top 3 boxes, so this is what happens when the browser sees your code. And this is taken from a talk, JavaScript Engines, the Good Parts, which was at JSConf this year. And the idea is that JavaScript sees your code, parses it into an abstract syntax tree, and passes it off to an interpreter. The interpreter runs your code, and if it sees the same functions being called a few times, it will do some extra work to optimize that function so that the next time it's called, it will be faster. Cool. So this is like it dynamically figures out which functions are important and optimizes them. So this is a thought I had. Could I do some redundant work ahead of time to give a clue to the JavaScript engine to optimize these functions so that when it comes time to use them, they are already optimized? So rather than waiting for the browser to optimize it, like trying to do some work ahead of time to get it to optimize it. Unfortunately, I don't have my pointer, so I can't step through this line by line, but I will do it just pointing my finger. So this is kind of the part of the equation. So in this function here, it's called schedule. I pass in a function that I want the browser to optimize. And I'm using, it returns a request idle callback. So request idle callback is a browser API that you can call to schedule low priority work to happen at some point in the future. So it won't interfere with other things going on the page. If it's busy, it's a super low priority thing. And in this loop, I have a few guards. And the idea is I'm just going to run this function in a loop, like to tell the browser, like, please optimize this thing. So I'll do it up to 10 times. So I'll try and do this loop 10 times. I'll exit if it takes more than 1 millisecond, or if the request idle callback says that you're out of time, and that's using that function there, deadline.timeRemaining. You can get only the idle callback might say, hey, you're out of time, you need to end. Cool, and we also cancel this if a user actually starts dragging, because there's no point warming up stuff if we need to use it. And so every single item on a page would do this. And we saw improvements of 25% in lift time, which is pretty significant by doing some kind of loopy, magic-y stuff. So that's the good news. The more surprising news might be that I didn't actually ship this. I had it in the code base for a while before it got released, and I pulled it out since then. And I'll give you some reasons why. I was on the fence for a while, but here we go. I actually have notes because it's pretty complicated. This optimization is extremely speculative. I'm basically trying to guess and force the browser to optimize these functions. And while it might work today, if they release a new version tomorrow, it might just stop working, depending on the heuristics of things. Even though I saw pretty consistent wins, those same kind of wins across all the browsers, it might change. And unless I'm willing to go in and test these things regularly to actually make sure it's still giving me the benefit of sort of adding this extra complexity to my code. So I have no idea if the numbers that I chose, like 10 times in a loop, 1 millisecond, will yield similar results across different hardware profiles. Like, it's just completely opaque to us how the browser actually will, or the engines will actually optimize things. And Chrome's talked about in the past how they do different things depending on the hardware profiles and like how much memory they have and all this kind of stuff. So this could just be a complete waste of time on certain devices. As I've said, lifting is already a very optimized thing that I've optimized before. So in like worst case scenarios, you're looking at about 30 milliseconds, which is pretty small. So 25% saving is about 10 milliseconds, which is not really perceivable to humans. And so in order to get that advantage, you need to do 500 milliseconds of CPU burn. So that's actually a 50-to-1 cost to benefit ratio. So you need to burn the CPU for 50 milliseconds to get 1 millisecond of benefit. And it felt like it was more of a glory metric for the library by just saying, yes, I made it faster, than actually being something that's useful to consumers. And if we think about CPU time as costing people money, like this actually costs people the cost benefit here is probably not in the right scale. Also, page load is important. Probably don't need to mention that, but it is important, and doing this kind of work and trying to put it up front is really trying to make react-beatutiful-dnd seem better, but it may be at the expense of something else. I was trying to be pretty guarded there, but you know, if you're ever pushing work forward, like you may be like clashing with things that you didn't want to. And I touched on this a little bit, but anytime you add like more code to your code base, like it gets more complicated, and it's more you have to maintain and more you have to test. And with this sort of speculative, funny optimization, I decided the cost benefit just wasn't worth it, so I took it out. Adventure for somebody else. Maybe in this room, maybe not. Will change. So will change is this really fascinating CSS property that you can set on elements, and what it actually says is that it's a clue to the engines to like get ready that this property is going to change. So you can say like transform is going to change, and browsers will optimize for that already, like do optimizations ahead of time. And they say don't use this very often because it actually forces the browser to do lots of work that it might not need to do, so use it sparingly. I'm thinking like, could we have something similar for JavaScript? Like what if you could just add a pragma to the top of a function to mark it as hot? Like right now we have dynamic optimization. Like what if we could give the compiler like more information to say, hey, please optimize this function because it's going to be super important at a really critical time and it's not going to be called many times before then. This is just an idea, but CSS have it, so maybe we can get it too. It's an idea. So that was my second story. You don't need to applause, it's fine. Anyway, you can save it up to the end. And the last story is being open. So this is a little bug that got raised about 2 months ago on the project for Beautiful-dnd. And in this particular list configuration, when you pull an item down to the bottom of another list, you can see kind of the auto scroll logic gets confused and you like jitters around. And the core of the issue was that there were these two functions that were trying to solve the same problem. They didn't have copy-pasted code, they were just looking at the same problem through a different use case and trying and had some code to deal with that. And there was a mismatch in how their logic worked. There was a slight inconsistency between how they were viewing the problem, and that's what caused this jitter. And so the answer was to consolidate that logic. And I kind of saw as well that actually these functions are doing this pretty heavy logic, both of them, on every single update for a drag. But it doesn't need to, this particular one, so we can just cache that value and store that forever. So we went from something like that, where they were both looking at the problem every single time and looking at it slightly differently, to a single function looking at the problem once and caching the result, which fixed the bug. But I found this particular experience very fascinating because a bug came in, and yes, the bug got fixed, but performance ended up being improved. It actually improved performance by about 5% in the application, which is like significant just for fixing a bug. And my personal experience working on teams is that it's so easy to discount bugs, especially bugs that we consider to be like paper cuts, and we need to focus on things that are more important, right? But what if we saw bugs as an opportunity to question the abstractions that we have rather than just a chore to be avoided? I talk about Beautiful-dnd like way too much because I'm really interested in it, but in the break tonight, I'd love to hear about like your stories and some of the interesting things that you work on, because I think it's very easy for me to become like so engrossed in what I'm doing, but I'm kind of over it. So I'm really interested to hear some of the cool stuff that you guys are working on. All right, cool. Thanks everyone. Any questions?
Yeah. I do have a question.
Oh yes.
You touched on it briefly. Sorry. You touched on it briefly how you chose those magic numbers to force the compilers to optimize the kind of magic numbers. How did you pick 10 times? Did you do a lot of trial and error? How did you figure out that it did optimize things?
Yeah, so measuring, yeah, it's totally trial and error. I tried to find a balance between doing enough work to get consistent, good results without being too heavy and making the CPU burn. The results did get better the longer you make the CPU burn, but it's sort of like this cost benefit, and those numbers there were like the sweet spot that I found, but that was just on my laptop, right? So it could have been different hardware profiles, which yeah, again, mine didn't end up actually doing it. I just thought it was a really interesting idea.
Any other questions?
Can you give us any more detail on like that explanation of like these two functions doing some work that are converting into one kind of problem solved? Can you give us any more detail on like what that work is, what you're able to kind of abstract out into that single point?
Yeah, so the question was about giving more detail about the auto-scrolling fix. I didn't go into it originally because it wasn't super important for the point I was trying to make, which was that a bug led to a performance improvement. But in this particular case, it was to do with when you move something into a list that isn't the list that it started in, we add some space to that list, and functions in different parts of the code need to be aware of that. And it turned out that the auto-scroller needed to be aware that like, hey, even though the dimension of the list is like, it's 100 pixels high, I've actually inserted another 20 pixels in there. So you need to be aware of that. And it gets complicated trying to calculate like max scroll position for a scroll list. When you add additional space into a list after the dimensions have already been captured, it gets super nerdy. But yeah, the gist is that we artificially insert space into a virtual model after it's already been collected. And both of these functions were inserting that space, but they were kind of doing it for different reasons, and they were using different techniques to insert that space. And so now when you hover over a list, on that virtual model itself, we say, hey, like, this currently has a placeholder in it, and we update all of the dimensions inside it to be as if they had that space inserted. And so then all the other functions just look at those raw values because they've already been updated. And then when you remove it, we stored a record of what all those things were, and then we just revert them all back to what they were before you went into the list. So we just do that inserting space logic like once in one place, and then everything else just doesn't even know about it. It just uses the dimensions. Yes?
So out of curiosity, are you using React lifecycle functions for this, or are you using the normal DOM functions for are you using React lifecycle functions like should update functions, or are you doing this directly in the DOM?
Yeah, so we lean on React super heavy, but we don't do anything really directly to the DOM. So as a consumer for Beautiful-dnd, we pass you everything through a render prop. So we don't like move or touch anything really. It's all on the consumer. But we just say like spread this and it will work. But we do during a drag like bind events to the window. But there's if you're interested in more of that, there is a guide on Beautiful-dnd that talks about how we use DOM events, and it goes through in detail like all the DOM events we use and how we use them and which ones we call prevent default on, which ones we don't, because people build experiences on top of Beautiful-dnd, so we have to be really clear about that. So when we shipped multi-drag, because that's like another interaction built on top of dragging, we need to just be very clear about what things we're using and when.
There's one up the back there, right after Sean.
Sure. Hey, this isn't actually a question, but congratulations on being the most popular drag and drop library for React.
Yeah. Yeah, we passed React-dnd in terms of stars, but so yes, go GitHub stars. Yeah, it's still cool. It's still very cool.